Alright, so in this class I've asked you to calculate percent composition just using the molar mass calculation system we've learned in this class. Okay? So if we're doing water, H2O, it means we have 2 hydrogens and 1 oxygen. What we want to know is the percentage of, by mass, of the hydrogens and the oxygen in the total mass of, say, 1 mole of water. So the atomic mass of hydrogen is 1.00794. We multiply that times 2. We get 2.01588. There's only 1 oxygen in the formula, so we just need one of those, 15.9994. You can see there's an empty slot here underneath the 8. We don't put a 0 there. I know you were taught to do that in math, but we don't do it in chemistry because putting an extra 0 in there is misleading people about the precision of the measurement that was made or the calculation that was made. So we're going to use, I use arrows, but just don't put a 0 there. So you add those together, you get 18.01, I'm sorry, it should be 01, shouldn't it? Not 528. Not 10, 01, 528. Hmm?
Whatever you're saying, you said
0, 1, 528. We're going to underline this last digit because we need to round it off. We need to know this is grams of H2O here, but the rounded answer, the correct answer is 18.0153 grams of H2O. And in this class we always say that's equal to 1 mole. This is essentially defining what a mole is by mass anyway, what molar mass is. It's the mass of any substance in 1 mole of that substance, and that equality statement defines that. But it also turns out that when we do this calculation that this is, in grams at least, the mass of the hydrogen in 1 mole of H2O, and this is the mass of the oxygen in 1 mole of H2O. Okay? And so using that we can calculate the percent. We can take this number, that's the mass of hydrogen, and the mass of the total, divide this by this and multiply by 100. So 2.01588 grams of H over 18.01538 grams of H2O times 100. Shouldn't have that 8 on there because I rounded that off. I don't want to wrote 3.8 anyway. It's 2.8, but it should be 3 here. And so that's the percent. We want to find our significant digits. This number has 1, 2, 3, 4, 5, 6 digits. This one has 1, 2, 3, 4, 5, 6. We want 6 digits here. 1, 2, 3, 4, 5, 6. So everything after that gets rounded off. And we round that to 11.18982% hydrogen in water, or in 1 mole of water. And so we do this to the calculation for the oxygen in the same way. 15.9994 grams of oxygen over 18.0153 grams of H2O times 100. round that off to 6 digits again. 1, 2, 3, 4, 5, 6. 88.810. Let's see, it'd be a 1 there, wouldn't it? 6 makes the 0 round up to a 1. And that's percent oxygen in 1 mole of H2O. Or just an H2O is fine. Okay? So that's your mass. Now, if you want to check your work, you'll add these two percentages together. If this is all the percentages, then when you add these together, you should get pretty close to 100. So let's see, 11.18982 plus 88.8101. Pretty close to 100. Okay? Any questions?
On the test, will there be one of those and the one